So I know that I didn't really go over Shannon and Simpson index that well in class, so if you do want to learn about them and you don't feel like sifting through all the complicated looking resources online, I will do it here for you. So the basic rule of Shannon's index is negative summation, sorry this is like bad handwriting, of piece of I multiplied by natural log of piece of I. Make sure to always say natural log, especially if you ever take BC, because the BC teacher takes points off if you say ln instead of natural log. Okay, so I'm going to use the same tree example. So let's say I have 4 types of trees in an acre of forest, 4 species if you will. Like these can be like the truffula trees from the Lorax. So pink trees, we have purple trees, we have green trees, and we have yellow trees, right? And these are all, let's say I count them and I have 20 trees all in total, right? Now, let's say I have 5 red trees, 5 purple trees, 5 green trees, or no, let's not do that actually. Let's have 6 green trees and 4 yellow trees. First thing I want to do to find piece of I is find my percentages. So if I have 5 out of 20 red trees, that means 25% of my forest is red trees, which is 0.25. This applies for purple trees as well. If I have 6 out of 20, that 30%, 0.3. 4 out of 20, 20%, goes to 0.2, right? So now from there I calculate my natural log of piece of I. So I'm going to do natural log of 0.25, natural log of 0.3, and natural log of 0.2. Get a calculator for that. Okay, so my natural log of 0.25, I'll go to 3 decimal places, is approximately negative 1.386. Natural log of 0.3 is approximately negative 1.204. Natural log of 0.2 is approximately negative 1.609. Okay? So that is our natural log of piece of I calculated. So now what we want to do is we want to find piece of I times natural log of piece of I. So that's going to be, for the first one, it's going to be negative 1.386 multiplied by 0.25, right? So I have it stored in my calculator, so I'm just going to use like the full value instead of my approximation. But you can probably use the approximation on the test. I don't think they'll care. So this is approximately negative 0.347. 0.3 multiplied by negative 1.204. It's approximately negative 0.361. 0.2 multiplied by negative 1.609 is approximately negative 0.322. Okay, great. So now what we do is we sum these up. If you've never seen summation notation before, all this means is that once you calculate all of them, you add them together. So I will be adding negative 0.322 plus negative 0.361 plus negative 0.347 plus negative 0.347 together. And again, the reason I add negative 0.347 twice is because there are 2 different types of trees that have 5 out of 20. I just only showed the calculation once because I didn't see the point in repeating it. But this happens twice. So again, you can use the approximation, but I'm just going to use the actual value I have stored. So once I add these all up, I get negative 1.376 approximately. Remember, there's this negative. I circled it, I don't know if you can see. There's this negative at the end of before my summation notation. So I have to multiply this whole thing by -1, and obviously that I just get 1.376. So this is my final answer for calculating Simpson's index. Oh no, Shannon's index, not Simpson's index, my bad.